All right, hi everyone. I'm Ariel from Hebrew University of Jerusalem. I'm going to present compact CNN for indexing egocentric videos. This is work done with Yair Poleg, Shmuel Peleg, and Chetan Arora. So we'll start with some motivation. Egocentric videos are nice because they allow you to see the world through the eyes of the camera wearer. However, there are some downsides, like the fact that the videos are long. They're boring and they're unstructured. Long because there can be days worth of videos, like we just saw. Boring because most of the stuff that we see just has no highlights in it. And unstructured because it's just continuous footage. So one approach to making these videos more digestible is by temporal segmentation into chapters. So one method of doing that might be by detecting what objects are in the scene, and then according to that, chapter the video. The other method is by asking what is the wearer doing, and that can be done using the motion of the camera, GPS tags, and such. We used motion of the camera. So I'll talk a little bit about optical flow for egocentric videos. The main challenge with using optical flow in these kind of headshot cameras is that head motion dominates the optical flow. So you can see in this grid, when we take sparse optical flow on, let's say, 32 by 32 cells, then we expect, if the person is walking forward, to see something like the middle frame. But what we actually see is a bunch of these sharp head motions when we look at the instantaneous optical flow. So what we need to do is look at a volume of optical flow over a few seconds. So our previous work in CVPR14 used handcrafted motions, basically smoothed the optical flow over a few seconds using SVM to classify 7 activity classes. And we got 70% accuracy then. So basically our goal now is to improve that, to expand the number of classes. So this is what we'd like to get to, given an egocentric video, say where we're driving, where we're standing, running, etc. And these are the 14 classes that we classified into. The bottom 7 are the ones from the previous work, and we added the top 7 in this work. So how are we going to do that? Obviously with the CNN. In this case, it's a 3-dimensional CNN. So basically what we do, here's an overview of the pipeline. We take the video, compute sparse optical flow, and then take blocks of 60 frames, which correspond to 40 seconds, and input those into a 3D CNN. I'm not going to go into the details of the architecture here. And basically obtain a classification for each block of optical flow, and then when we string them all together, we have the classification for the entire video. So here's a comparison of the results that we got compared to CVPR14. The error rate was reduced from 30% to 11%. We have an improvement over all the classes, and overall rate of 89% accuracy on these 7 classes. On the 14 classes, we have 86%. We have some nice results in transfer learning and some other things. Come to your poster, read the paper.